Okay, Math 1000, section 7.2. How do you rewrite these in exponential form? Number 7, you've got x to the 5/2 power. I'm just going to go down. Number 11, you have z to the 5/3 power. 9 to the 7/4 power. A to the 3/4. B to the 1/4. So what you're doing here is your radicand is x, your numerator is 5, and your index is 2. Your radicand is z, numerator is 5, index is 3. So going across. This one would be b to the 3/2 power. X to the 11/3. X to the 9/2. X to the 4/3. Y to the 1/3. We have a 1 understood here, 1/3. 9 to the 5/2 power. 7 to the 10/3. Y to the 14/3. X to the 9/4. Z to the 5/4. Next. Now we are going to write these in an exponential form. So, number 27. You've got a to the 1/2 power, so that's just the square root of a. 31 is 18 to the 5/3 power. That's the cube root of 18 raised to the 5th power. And 11b squared c would be, and it's to the 3/5 power, so that's the 5th root of 11b squared c, all of that cubed. 28 is the cube root of a. 32 would be the 6th root of y to the 17th power. 36 would be the 4th root of 8x cubed y squared. All of this to the 7th power. And we've got the cube root of a squared. We've got the square root of 24x cubed. And for this one, they're trying to trick you with this plus sign here, but 1/5 means the 5th root. The index is 5. And all this is 6a plus 5b. All of this is to the 1st power. Okay, the next set. These ones you're going to simplify. 41. A squared. If you rewrite these in exponential form, sometimes it's easier. So a squared, the index is 2. So 2 over 2 is 1. So it's a to the 1st power. This one, 6 over 3, is 2. You've got 9 over 3 here. Well, that's easy, that's 3. And 12 over 4, that's 3. Some of these are easy because you don't have to do much. If you have 2 of these and it's square root, it's just 19.3. You've got 4 of these 6.83s and you need 4, their index is 4, so it's just 6.83. Now this one, it's saying that you have, I would do this, I would rewrite this piece first. So you've got x, y squared. All of this is to the 1/3 power. So if you distributed this, this would be x to the 1/3 times y to the 2/3. And you're going to raise all this to the 15th power. So power to power, you're going to multiply this times this and this times this. Those power rules you really got to watch. So if you were to distribute 15 times 1/3, you get x to the 5th power. 1/3 times 15 is 5. And then y, if you multiply, 3 goes into 15 5 times. So you have a 2 here. 2 times 5 is 10. So that would be your answer for that one. Same with this one. I would, before you do this 40, I would rewrite this as a to the 4th, b to the 1st, c to the 3rd, and this is to the 1/4 power. So you're going to distribute this. This times this is 1, so it's a to the 1st power, b to the 1/4 power, and c to the 3/4 power. You're going to raise all of this to the 40th power. That's what that is. So your answer would be 40 times 1 is 40, so a to the 40th. Now 40 times 1/4, the 4 goes into 40 10 times, so it's b to the 10th. And then the 4 goes into the 40 10 times, 10 times 3 is 30. So that's your answer. Next one. Now what you could do is, you could do this. For this next one, you could do 4 divided by 8, which is going to give you 1/2. So this is going to end up being, you could do it this way, x, y, z to the 1/8 power. So it's x to the 1/8, z, y to the 1/8, z to the 1/8, but then you're gonna, that is a 4, so you have to distribute that, which is gonna make all of these 1/2, because 1/8 times 4 is 1/2. Oops. $54. Or what you could do is just, you could divide these two if you wanted to. But I like to do it the way that you could see, work with the entire problem, where it's a squared, b, c to the 4. I want you to raise this to the 1/9 power. Distribute this. So this is going to be a to the 2/9, b to the 1/9, and c to the 4/9. And then you are going to cube this. So this is going to be 3 times this, 3 times this, 3 times that. So if you were to multiply 2 9ths, and I'm going to do it on a separate sheet of paper, just because you need a little practice, 2 9ths times 3, what happens? 3 goes into 9 3 times. So this ends up being 2/3. So you have a to the 2/3 power. And then you have 1/9 times 3. 3 goes into 9 3 times. So you have b to the 1/3. And then you have c to the 4/9 times 3. And that would be 4/3. Now, can you write this a different way? What do you know about these indexes? They're all 3. And then you have a squared, b, and c to the 4th. So what did they do with this 3 and this 9? They just reduced it. 3 over 9 is 1/3. So that was another thing you could do. Same with this, if you go backwards here, you could have done this to that problem. 4 divided by 8 is 1/2. You could have turned this into x, y, z, and then 1/2 power. 1/2. Because 4 over 8 is 2. Just reduce that, just like you did here. 1/3. Okay, next one. This one, this is the square root of x. This is written x, you're going to go inside here. This is written x to the 1/2 power. And then this is the 1/2 power. So you have to know power to power, what do? You multiply these, so it's x to the 1/4 power. 56. This middle piece right here is a to the 1/3 power. And then the outer piece is the square root. Square root means 1/2 power. So power to power, you multiply. 1/3 times 1/2 is 1/6. $57. This is y to the 1/4 power. And then raise it to the 1/2 power is y to the 1/8. 1/4 times 1/2 is 1/8. This middle piece right here is b to the 1/4 power. And then you're going to take this and raise it to the 1/3 power, because it's the cube root. 1/4 times 1/3 is 1/12. Ooh, 59. You've got this piece right here. Let's do that first. This is going to be x to the 2/3, y to the 1/3. You're going to raise all this to the 1/3 power. So power to power, you're going to multiply these two. So you get x. These two multiplied is going to give you 2 9ths. And these two multiplied together is going to give you 1/9. And the last one in this set, 7y to the 1/3 power. Now see how I'm putting this whole thing in parentheses, 7y to the 1/3. So this is 7 to the 1/3 and y to the 1/3. And then you're going to raise all this to the 1/4. So it's 7 to the 1/12 power, y to the 1/12 power. Okay, the next ones. Evaluate if possible. This is asking you, what's the square root? What's the square root of 9? Well, we can do the square root of 9, it's 3. What's the square root of 100? That's easy, that's 10. What's the cube root of 64? 4 times 4 times 4? That's easy. 64 to the 2/3 power. This is asking you, what's the cube root of 64, but we have 2 of them. So if I wanted to think about this without a calculator, I've got 64, but I've got 2 of them. Okay? Well, if I know if I have 1 of them, the cube root of 64 is 4, right? 4 times 4 times 4. So I've got 4 here, but I've got another 4. So what is 4 times 4? 16. Next one. 27 to the 2/3 power. Again, you're taking the cube root of 27, but I've got 2 of them. So I've got 27, 27. Well, one of the 27s is 333, and another one is also 333. So you got 3 3s here and 3 3s here. So 3 times 3 is 9. That's my answer. 69, I can't do this one because I can't take the square root of a negative number. So this one's no solution. 71, I can take the square root of 25 and the square root of 9 and get 5/3. I can take the square root of 100 and the square root of 49 and get 10/7. I can take the cube root of 1 and the cube root of 8, I get 1/2. Now what's the difference between these two? They're totally different. This one has parentheses, this one doesn't. But are they the same or are they different? They're different. This one is saying, I want you to take the square root of negative 81, which you can't do. Not until you get to imaginary numbers. But this one is saying, I want you to take negative 1 and then multiply it by the square root of 81, which is negative 9. As long as that negative is not in parentheses, you're fine. And this one is saying, take the cube root of 64, which is 4, and then multiply it by negative 1. So this answer is negative 4. You can do that. Not a problem. Now, what's the difference between a negative exponent what is the difference between a negative exponent and a negative number? Well, a negative exponent means just bring it in the denominator. So this is saying negative 1 over 64. I want you to take the cube root of that at the bottom. So this would be 1 over 4. This one, same thing. I want you to take the square root of 49 in the denominator. So this would be 1/7. And this one, I want you to take the square root of 16, but I got 3 of them in the bottom. So what do I have here? I have 1 over, I've got 16, 16, 16. So the square root of 16 is 4. 4 times 4 times 4, which is, so this is going to be a 4 times 4 is 16 times 4 is 64. So this answer is 1 over 64. Next one. I want want you to take the cube root of this, but you're gonna flip it. Now these ones you can use, if you want, you can use a calculator. What you're going to do is flip this, and then you're gonna take the cube root. Now what you can do is, since it's a fraction, you can flip both of these. You can turn the 27 into the numerator, and you can turn the 64 into the denominator, and then you can take the cube root of the whole thing. So your answer is going to be 3/4. Now, this one, this index is a 4. And right away, because I have a negative number under here, can't do it. So this one is no solution. And same with this one, the index is 2. Can't do this one either. Last set of problems, 91. We have to apply these rules. If bases are the same, they want you to simplify. It says write the answer in exponential form without negative exponents. Okay, your job is to write them in exponential form without the negative exponents. Well, if these bases are the same, you're going to add these exponents. So this would be 4 1/2. Now, there's different ways to write this. You should write this as 9/2. Now, another way you could write this as x to the 4th times the square root of x. That's another way of writing that. Same with 92. You could write this as x to the 6th times the square root of x. This one is a division. If bases are the same, you should be subtracting. If bases are the same, you are going to do 1/2 minus 1/3. So what's your common denominator? It's a 6. So multiply this by 3 and this by 2. So it's x to the 1/6. That would be your answer. Next one, it says write this in exponential form without negative exponents. This would be 1 over x to the 6/5. Number 95, you're going to multiply these two. 1/2 times -2 is -1, but then they don't want a negative exponent. Power to power, you're going to multiply these two. -1/3 times -1/2 is 1/6. Multiply these two. Subtract. So you have 4 minus -1/2. So this is going to be 4.5. And 4.5 is 9/2. Now for 99, you're going to reduce. 5 goes into 60 12 times. So this just reduces to 1/12. And now for this, you've got, these are both the
Thank
same.
the following students to, the following teachers to the counseling conference room for staffing: Sheila Saki, Heather Blanks, John Pizzo, Jennifer Frank, Peter Doro, Susan Corrales,
So negative 1/3 minus, you have to
Kreiner,
subtract
Ms.
these two,
Coleman.
minus
Sir,
negative
please report
2.
to the counseling
You're
conference
going to
room
take
for
these two
staffing.
and turn that into a plus. Multiply this by 3, multiply this by 3, so this is 6. 6 minus 1 is 5. So this is going to be y to the 5/3 power. Next one. These bases are the same, so you're going to add these two exponents because you're multiplying. So what is negative 1/2 plus negative 2/5? Well, it looks like I've got to get a common denominator. My common denominator is going to be in tens. So multiply by 5, multiply by 2. So it's x to the negative 9/10, or 1 over x to the 9/10, because they don't want negative exponents. 101. For this one, 101, the 4 times the 3 is just 12. So that and that you just multiply. Now what you have to do here is add 5/3 plus negative 7/2. Because if bases are the same and you're multiplying, you have to add these two exponents. So now I've got to get a common denominator. Common denominator would be a 6. So multiply this by 2, this by 2. Multiply this by 3, this by 3. So this would be x to the negative 11 over 6. Or it's going to be 12. And then I'm going to bring this in the bottom because it's a negative exponent. So this would be, 12 over x to the 11/6 power, because it's a negative. This became, I multiplied this by 2. So this by 2, so you get 10. This by 3, this by 3, you get negative 21. When you add these, you get a negative number, negative 11. Negative 11/6 is your exponent. So we don't want a negative exponent, so you have to bring it in the bottom. 102. Power to power, we have to multiply these two. So this is going to be negative 4/15 or 1 over 4/15. 1 over 4/15. Now we have a fraction. See if you can simplify what's in here first. Well, obviously 3 over 28 is 3 over 24 is 1/8. And you can take the cube root of 1/8. This is saying the cube root of 1/8 is 1/2. That's the cube root of 1/8, but then you still have this down here. So I would leave that in the bottom. You could do that. This one, 2 goes into 54 27 times. It's And then they want the cube root of that. Well, the cube root of 27 is 3. And then this one, you've got the cube root of, you've got 4 of these x's. So you can take an x out, but then you'd still have 1 left. If you wanted to simplify it that way. And we've got 2 goes into 22 11 times, or you can distribute. There's a lot of different ways you can do this. 2 goes into 22 11 times. I would do that. And I would subtract these 2 exponents. So you've got x 3/7 minus 1/2. And then don't forget, you're going to have to square this. So you're getting a common denominator here, which is 14. Two, 2, 7, 7. So this is x to the negative 1/14. And now let's bring this in the bottom. Whoops, 1/14. Square it. So if you square this, you get 121. And then if you square this, you're going to multiply this by 2. You get x. 2 goes into 14 7 times. So you get x to the 1/7. So 1/14 times 2, that's where the 7 comes from. And the last problem in this set. You could multiply these both by 2 first if you wanted to, and then subtract. Or you could subtract and then square. It's totally up to you. So or you could reverse them, whatever you want to do. It's all on how you want to apply the rule. So if you want to multiply this by 2, what is 1/3? So what is 1/3 times 2? It's 2/3. So you have x to the negative 2/3 over 2 times negative 2 is negative 4. And now you're going to subtract. You have negative 2/3 minus negative 4. So you're going to get a common denominator here. So I'm going to multiply this by 3 and this by 3. So this is going to be 12. 12 minus 2 is 10. So it's 10/3. So you have x to the 10/3. So this answer is x to the 10/3. And that concludes 7.2.